Another video on how do we do the system design. So today we're going to talk about something called as distributed transactions. What do we mean by distributed transaction, and what are the challenges in terms of persisting these transactions into two different databases? So we will actually talk about what is the problem with the single ACID transaction. If you don't know what ACID means or what cap theorem is, you can check my video here and try and understand what this actually means. uh, so we'll talk about what's the problem with that. We'll also talk about 2PC, which is two-phase commit. So if we can't do with this, then how do we actually make use of two-phase commit, and what challenges two-phase commits could actually bring to the table, and how do we solve the problem which is exposed by two-phase commit, and if we can't do two-phase commits, what does actually Saga pattern offers us. And when we talk about Saga pattern, it actually comes with two different flavors. One is called as choreography and another is called as orchestration pattern. So let's try and understand what do we mean by distributed transaction, and then understand the problem with the single ACID transaction. So let's try and understand what distributed transaction means. So now when we are actually dealing with the databases, let's take an example of customer and a order table, right? So it is pretty common example wherein customer is trying to place an order. Now whenever customer places an order in a monolithic way, a single application is responsible to update the customer record and also update the order record, and tie them up so that system knows that the customer has placed an order. Now this is a single ACID transaction. Now if we are breaking this monolith into distributed system, now we would need to split these two different transactions, because we can't actually have one single transaction to update both customer table and the order table, right? So this is our customer table, this is our order table, right? So now these are two different transactions. Now in order to complete this transaction, I'll have to first issue a commit on the cust, and then also an issue on the order. Now this is something what we call as a two-phase commit, wherein we are committing on one table and also on the another table. Now this actually brings up a different problem altogether, wherein we we really don't know what has happened with this order commit, and if there is any issue with this order commit, are we in a position to roll back this particular commit? We possibly can't do that in an effective manner. And similarly happens with the order, right? And since these are handled in a serialized way, this actually adds to the time taken by the system to process this particular request and send back the response. This is actually something which would lead us to a solution, or a solution where we think this solves a problem which is known as a Saga design principle. So let's try and understand what that means. Saga design pattern is basically a pattern which actually solves the problem with two-phase commits and try and solve the overall issue with the distributed transaction. This is very popular design pattern that we have. It actually comes in two different methods. One is called as choreographer and another is called as orchestrator. Now let's try and understand what choreographer does, right? So let's say I've got two services. One is order service and another is a customer service. So if my system A wants to create an order and then ensure that it is also reflected in the customer service, eventually the customer database. So what it does is it calls this particular service. Now order service actually creates a row in the database and then publishes the event that yes, it has created the row. And now once this is published, there is a listener on this particular service, on this particular event, and that is the customer service. Now customer service is a subscriber of that particular service, so it understands. So there is an event, so what it does is it creates a table, it creates an entry on the customer table, and once that is created, what it does it then publishes an event saying that yes, it has successfully now created that particular entry. And once this event is published, now order service is now listening to that event, and once it understands that event has successfully completed, what it then does is actually commits to the database, and that's how it actually handles this particular problem. Now let's try and understand how orchestrator works, right? So this actually works on the pub sub model, but this actually works on a message broker model. Now what happens is, again, system A is calling the controller to manage this order, right? So once the order is placed on the controller actually takes care of creating, calling the order service first. Now once the order service is called, what it does is actually creates an order and creates, create an entry into the order table. Once that is done, it actually places a message onto a channel, which is as part of a message broker. It puts a channel on, sorry, it puts a message on a channel saying that, yes, I have done this. Can you please go ahead and create an entry on the customer table? Now this is, as this service is listening to this particular channel. Now once it receives the message that it needs to create an entry, it it goes on and creates an entry into the customer table. And once it is created, it tells to the reply channel that, yes, I have created this entry. Now you can actually go ahead and commit to it. And if there are any issues in creating that, it actually also takes care of it and responds accordingly. So let's take a sunny day scenario wherein it has actually created a row and puts a message saying, yes, on a reply queue saying, yes, I have actually managed to do this. Now can you please go ahead and commit your order to the database? And as we can now see, we are now able to manage two different transactions with, with a very minimum impact onto the system, and it is done really beautifully in this particular design principle. Well, that's how we manage the distributed transaction. It is one of the very popular design principle, as I had said earlier, in terms of managing transaction at different databases. That's all for today. Let's meet in some other video with some other challenge and some other possible solution. Thanks for now. Bye.